because if you reduce your inventory level, inventory means you are holding working capital. Your return on investment will increase, your cost will decrease and your profit will increase. So in this unit, we will discuss various aspects of material planning and control and present differentiations in management within push system, pull system and push-pull system. Now, so to know what is push system and pull system and push-pull system, we'll go back to supply chain because these are the strategies of supply chain. What is supply chain? Supply chain is also known as logistics network. So it consists of suppliers, manufacturers, warehouses, customers, as well as raw material, work in process and finished goods that flows between the facilities. If you see this figure, so this is manufacturing. So here, this is manufacturer. So suppliers, they supply the raw materials and components to manufacturer. Then manufacturing takes place, processing takes place from raw materials to finished products. Then finished products goes to warehouses where you store the materials and all, and then it goes to your customer. And there are various costs associated with it. One is manufacturing cost, one is transportation. This is your inward logistics, outward logistics. So these are all the costs. So what is supply chain management? That means managing the supply chain. So the skimpy definition of supply chain management is efficiently integrates all the supply chains. What are those? Efficiently integrates suppliers, manufacturer, warehouses and stores so that the merchandise is produced and distributed at the right quantities to the right location and at the right time in order to minimize system-wide cost and satisfy service level requirement. These are the two major objectives of supply chain management. Minimizing not the only one functional area, minimizing the total system-wide cost and satisfying the service level requirement. So this is the supply chain. So here first, if we see independent supply chain means, so here is the manufacturing unit. Independent supply chain means purchase department, production department, distribution department, they are separate. In internal supply chain, you integrate purchase, production and distribution. This is called internal supply chain. This is your materials management. Then you integrate the external part. Here in external part is suppliers. Here external parts is customer. So you integrate suppliers and customers. This is your external supply chain management. So supply chain management revolves around efficient integration of suppliers, manufacturers, warehouses and stores along with customers. So challenge in supply chain integration is to improve performance in following areas. One is cost reduction across the chain, increase service level, reduce bullwhip effect. We'll see what is bullwhip effect. It's an important subject in supply chain management, and respond effectively. So these challenges are made by integrating the front end and back end. This is the front end, this is the back end. Back end supplier, front end customer. So studying supply chain strategy helps us to design the supply chain. So the different strategies are push strategy, pull strategy and push-pull strategy. So we will discuss in detail what is push strategy, what is pull strategy and what is push-pull strategy. Then coming to push strategy. So here production and distribution decisions are based on long-term forecast. If you see this figure will tell about the difference between push strategy and pull strategy. Push strategy means you forecast the demand, the market demand you forecast, then you produce the material in the manufacturing unit, then you give it to distributor will give it to a wholesaler will give it to retailer, then customers. So here forecasts are based on retailer order. So retailer will give orders. So according to that, you forecast in the manufacturing. So it takes much longer time to react to the market change, which leads to the inability to meet changing demand pattern, obsolescence of inventory as demand for certain product disappears. Because you forecast the thing, you manufacture. Forecasting is always associated with an error. Right? Suppose before your cricket one day World Cup final, how many people have forecasted that Australia will win? Right? So forecasting is always associated with an error. Right? So that is why you have problem in push system. Next is bullwhip effect. The bullwhip effect is a supply chain phenomenon describing how small fluctuation demand at the retail level can cause progressively larger fluctuations in demand at the wholesaler, distributor, manufacturer, and raw material supply level. See, if we see this figure, bullwhip effect, actually the bullwhip effect was coined by Procter & Gamble company. Procter & Gamble was manufacturing baby diapers. So what they observed that if we see the birth rate of baby is almost constant in any country. So if the birth rate is constant, then the use of baby diapers also is constant in a year. But they see that it is fluctuating. The variability of the order, if in customer, they fluctuate this. And manufacturer, it is amplified. Fluctuations is more. Order variation is more. Supplier, it is still more. Right? So this is a problem in our system. We'll see. Bullwhip effect leads to, you see here, suppose customer order varies a little, retailer order increases, variation of order increases, distributor again increases, manufacturer again increases, suppliers again increases. Right? That means, suppose here, manufacturer will order some raw materials, huge raw materials, then after, suppose in the next 3 months and all, they don't give any order. So suppliers have problem because supplier wants that the demand should be constant. Right? So that is the problem. So this leads to, bullwhip effect leads to large safety stock, because to serve to your customer, you have to have large safety stocks. As suppose supplier, manufacturer, suppose this month it is asking 5,000, next 3 months 000, next 7,000. So to cater to this manufacturer, suppliers safety stock has to increase. So larger safety stocks. So excessive inventory means you are adding values. Production batches varies, as we have seen here. Then service level also decreases. Inventory obsolescence, because you are producing some and you are keeping this, and there are some alternate materials comes, means so inventory obsolescence. So it results in high manufacturing cost. Generally manufacturing cost increases, high transportation cost, and higher inventory cost. So here if you see customer, suppose customer order fluctuation is this, then warehouse, manufacturer order fluctuation is more, distribution order fluctuation is more, and supplier it is highest. So this is known as bullwhip effect, and our aim is to reduce this bullwhip effect. Then what is pull system? As we have seen that push system is forecast driven. You forecast from the market, you make in the factory, then you stock it. So this is make to stock, push strategy. What is pull strategy? Pull strategy means you don't manufacture unless there is a order. So customer order comes to factory, then only they will start manufacturing. They manufacture the product, they sell it to customer through via media. So production and distribution are demand driven. So they are coordinated with true customer demand rather than with forecast demand. So in push product, you forecast the demand, you produce. But here you produce according to the actual customer demand. So here your inventory is high. Here there is little inventory because what is the order? You are producing that. So in pure pull system, the farm does not hold any inventory and only responds to the specific order. Specific order comes, it procure the material, process it, then finished product, distribute to the customer. So this is possible by fast information flow from point of sale data to various supply chain participants. We'll see in the next slides. So pull system leads to decrease in lead time because customer wants the material means you have to supply him within stipulated time. So your lead time should be minimized and decrease in inventory across supply chain. So it is difficult to take advantage of economies of scale in manufacturing and transportation because suppose customer order is X, your economies of scale capacity is 2X. You cannot wait for another X. So you have to process the materials and supply. So it is difficult to implement when the lead time is long because customer dissatisfaction will be there. Then this is push-pull system. Here in push system, the manufacturer takes the material from raw materials and components from supplier, manufactures the thing according to the market forecast, then it goes to distributor, through other intermediaries, it goes to customer. So it is forecast driven. In pull system, it is order driven. That means customer will give this point of sale data, POS, this goes to distributor, here it goes to manufacturer. So manufacturer, suppose n number of items, order comes for n number of items to manufacturer. So manufacturer will procure this proportionate amount of all the components and raw materials from different suppliers. So all the raw materials and component, it comes to manufacturer manufactures, distribute to customer through intermediaries. So this is the information flow, dotted line. This is the product flow, and the faint one is the reverse logistics. Suppose customer is returning something. This is reverse logistics. So this is push logistics, pull logistics. If you see the characteristics of push and pull, push is make all, we can just in case. So here communication is poor because you don't know the feedback, you forecast and you supply. So high inventories, you have to keep high inventories because you are manufacturing, suppose market is not, your forecasting error is that means inventories will be high, then waste also will be high. Large lot you have to produce, you take into account the economies of scale, production approximation, then management by firefighting. That means all the reactive, these things you have to do. But in case of pull system, small lot according to the actual order of customer, better communication because customer order comes, then you start manufacturing. So communication is better. Waste reduction, management by site. That means here the top management, they involve all the employees. That means the employees also, they think we are the part of the system. So this is management by site. Actual consumption, according to the order you produce, so actual consumption. So that means low inventories and production precision. So characteristics of push and pull. Objective push is minimize cost. Why? What is the point here? Because economies of scale. You are utilizing the capacity. But pull system maximize service level. It should be responsive. When the customer asks, you give it to them in least time period. Complexity push is high, complexity pull is low. Focus is resource allocation in push. And here is responsiveness. Responsiveness means time. So this is cost, this is time. We are reducing cost here, we want to reduce time. Lead time, as we know, for pull it should be short, and for push it is long. Processes are supply chain planning, here order fulfillment. Then next is push-pull system. Third one is push-pull system. Here, if you see, this is push strategy, this is pull strategy, this is the push-pull boundary. This is the supply chain timeline. Supply chain timeline means, suppose customer orders a product, the timeline starts. That means manufacturer will procure raw materials. So this is the time starts and you supply to the customer. So this is the total supply timeline. So here what we do, the interface is known as push-pull boundary. This dotted line is push-pull boundary. Suppose take for example Dell manufacturer. Here for assembling a computer, you need lot of accessories. So you forecast these components, you procure item and you manufacture these components. So this you keep it in your inventory. So this is push strategy. Then a customer wants, suppose TCS wants from Dell that 2000 systems with some specific customization. Then so here the pull part starts. That means they will assemble according to the TCS orders. So pull part starts here, right? So this is push, this is pull. So this interface is known as push-pull boundary. Example, PC manufacturers Dell component inventory is based on forecast push, whereas assembly takes place when customer orders item. So push-pull boundary is the beginning of the assembly. So here, this is push-pull boundary. Example, postponement or delay differentiation. I'll give you one example which will clear you, day-to-day example. Suppose a South Indian restaurant, a South Indian tiffin hotel, right? So morning if you go, so if you observe, they have idlis and vara, they have idlis, vara, and your dosa. So idli and vara, how they make? They use pull strategy. They know that the transaction means the sales will be this. So previously they make idli and vara. So it is push strategy. Then suppose you order for dosa. So what they will do? So they have the batter, this masala, potato masala and all. So they will prepare this and give it to you. So that is actually push-pull strategy. Because the batter and aloo masalas and all, they have already made this one. So that is the push part. And if a customer orders, you start manufacturing. Right? So that is the pull part. So this is push-pull. Your dosa is push-pull. What is pull? Suppose in August 15 or January 26, a school orders 500 units of tiffin. It consists of bara and samosa. So what they will do? For this 500, they procure separately all the raw materials and all vegetables. So that is pure pool, right? And then here we will see the matching supply chain strategy with product. So x-axis is your economies of scale. Here economies of scale low, economies of scale high. In vertical axis we have demand uncertainty, low and high. Higher demand uncertainty, pull strategy. If we go here, demand uncertainty is high, pull strategy. Higher economies of scale is push strategy. So here is pull, here is push. Now, box 1, just 1. Here, box 1 is computer. So in case of Dell. So in Dell, demand uncertainty is high. You don't know what will be your demand and what will be your configuration. But here economies of scale is low. So this is pure pull strategy. So computer assembly manufacturer, they use pure pull strategy. Box 3 is your grocery, all this fast moving, FMCG, right? So here demand uncertainty is low because more or less you know the demand, and economies of scale is high. So this is your pure push strategy. So this is pure pull, pure push. Then box 2 is furnitures, automobiles and all. So here demand uncertainty is more, but economies of scale is high. So here you make some components, then you assemble according to the furniture orders or automobiles. So this box 2 is push-pull strategy. And box 4 also, these books, CDs and all, this is also push-pull strategy. So here computer 1 is pull, 3 is push, these 2 and 4 are push and pull. So push-based material system. So this is forecast-based systems. It aims at maximizing production and distribution functions. And the application is steady and dependent demands. We know there are 2 types of demand. One is dependent demand, another is independent demand. Dependent demand, when the relationship among the items or components can determine which final product is dependent. So in dependent demand, we require material requirement planning. Demand of car, demand of final product is independent. But demand of auto parts, demand of say axle, demand of tires depends on car. So these are all dependent demands. Material requirement planning, it uses master production schedule. Now we will discuss the importance of MR and MPS, master production schedule. Master production schedule is what is to be made and when. Suppose in case of this COVID, Andhra Pradesh government has given order for 1,000. So master production schedule will tell to material requirements that 10,000 this type of customized ambulance has to be made. The time phase plan specifying how many and when the firm plans to build each item. So flexibility within a master production schedule depends on the several factors. One is production lead time, next is commitment of parts and components to an end item, then relationship between vendor and customers, amount of excess capacity, and management willingness to change. So here it shows the master production schedule, the input and output of master production schedules. First is customer order on hand. What is the customer order you have? So this is one of the input. Then parent product forecast. Then you forecast what is your Next, order forecasting. So customer order, actual order plus forecasting. Then what are the resources you have? These three are the inputs of master production schedule. And of course other customers and order priorities. Suppose say, as we have seen in pandemic time, you have to block all the items and you have to, or you have to manufacture only the COVID related item, specifically designed for ambulance for COVID, right? So this is the priorities. So these are the inputs for master production schedule, and the output, that 1000 number of ambulance, is the input of this material requirement planning system. So output of material MPS, master production schedule, goes to this material requirement plan. Suppose say this, what is this bill of materials, BOM. This is a roller skating. Suppose for a roller skating, what you want to manufacture one roller skating, you want one this boat, this black boat, you want one. These trucks, these are called trucks. You want 2 trucks for front and rear. Then each trucks have 2 wheels. So here 2, 4 wheels. And here you have 4 screws. Here you have 4 screws. So total 8 screws. So this is called bill of material. That means to manufacture one these components, you need these items in these numbers. So this is the bill of materials. So bill of material is a comprehensive list of parts, items, assemblies, sub-assemblies, intermediate assemblies, and other materials required to create a product, as well as instructions required also for gathering and using the required materials. So it can be thought of as a recipe and shopping list for the creation of a product presented in the hierarchical form. So the bill of material includes instructions for how to assemble the product from the various parts that need to be sourced and built. Now we'll see how to calculate this material requirement plan. We have an example. See this example. Material requirement planning computations through examples and step expressed in table 1. The demand, that means the gross requirement for a part A from master production schedule is this. As we have seen in the previous slide, that master production schedule, the output of master production schedule is the input of MRP material. So the output from master production schedule is we have 1, 2, 3, 4, 5, 6, 7, 8, and demand is 15, 20, 50, 10, 30, 30, 30, 30. So master production schedule, they have given this to material requirement plan. So here we assume that no scheduled receipts, on hand inventory is 30. That means opening inventory here 0 means you have 30 inventory. Lot size is 75. That means when you are ordering to your supplier, so you have to order 75 units, not less than this. And the lead time is 1 week. That means if you supply in this week, you will receive the material in next week. So we'll determine the net requirement. So 0th week, we have 30 inventory items as the opening inventory is 30, right? So here week 0, 1, 2, 3, 4, 5, 6, 7, 8. Demand is this demand from master production schedule 15 to 30, and on hand is 30, right? So we'll calculate the net requirement. See carefully. In 0, our opening inventory is 30. In first week, demand is 15. This 15 is our demand. So from 30 we take 15. So on hand we have 30 minus 15 is this 15. On hand we have 15. Okay. Next week 20 is the demand. We have 15. So 15 minus 20 is minus 5. That means we want 5 materials. Net requirement is 5. So this is the net requirement. In second week is 5. Third week we don't have any inventory in our hand. So demand is 50, requirement is 50. So on. We don't have any inventory here. So as per the demand, we have the requirement is this. Okay. Then going to next slide. So here weeks, demand and on hand. This is as per previous slide. So now we will see net requirements we have calculated in the previous slide. So our previous slide was up to this. This slide was up to this net requirements, up to net requirements. Now we will discuss what is the planned receipt order. So in 0 week we have 30 items. Right? First week we don't require. So here in second week we require 5. Our net requirement is 5. So as we have discussed, we cannot give order for less than 75. So we give order for 75. So here we have to receive 75 order. Suppose we receive 75, 5 goes, now it is 70. Third is 50 is the requirement. So 70 minus 50 is 20. So here minus 10, you have 10 here. Opening inventory, net requirement is 10. 10, but you require 30. So you want 75. Right? So 75 plus 10, 85 was there. So 85 minus 30 is 55. So here also you require 75. So in second week and fifth week and seventh week you require 75 items. But when you have to place the order, you have to place because the lead time is 1 week. So before, suppose you want order, you want the material in second week, so you have to place order in first week. This 75 you have to place order. For this 75 you have to place order in fourth week, and plus this 75 you have to order in sixth week. So first week, fourth week and sixth week. See this. So this first week, second, third, fourth week and sixth week. You suppose you order here for 75, you receive the materials. So this is the computation part. And here we will see the inputs and outputs of materials requirement plan. We have discussed in our very first slides the importance of material requirement plan. It has played a significant role in any firm, in OEM firm and other. So material requirement plan, what are the inputs? Main input is from master production schedule. So master production schedule, they give means mostly the forecasted order or the order they have. Then bill of material, for that order, what are the components and all needed. Then current inventory. Current inventory status also, it is the input. So master production schedule, bill of material and current inventory record, these are the MRP inputs. Then the process, what are the outputs? The outputs is how much you produce and how much you purchase. This is the planned purchase order, planned manufacturing schedule. So this is the output. Then The disadvantages is based on forecasting, not applicable to make to order pull system. It uses capacity utilization, may result overproduction and excess inventory. Some cases lead time increases. In some cases your lead time increases. Why? Suppose the maintenance or breakdown or power failure or logistics delays, or there are some hartals and strikes. So change in market order leads to nervousness. So we have to determine the lot size. Lot size is one economic order quantity and another is periodic order quantity. So economic order quantity means it is that level where ordering cost and carrying cost are equal and the total cost is minimum. If you order in that economic order quantity, your total cost will be minimum. And the periodic order cost, the periodic order cost translates the economic order into time units. Suppose in your house, the yearly consumption of sugar is say 60 kg, you have large family, and EOQ is 5 kg. So 60 divided by 5 is the periodic, the time required. So then pool based system, it is alternate to push based system and classical MRP approach. Reason for this development is due to increasing varieties based on customer orders and customization. It reacts as per the customer order. So pool production is opposite to push, because we have already seen that push means forecast oriented. According to the market forecast, you make the product and push to the customer. So here, according to the customer demand, you make the product, right? So push system is make to stock. You make, then you stock, then it goes to customer. But pull system is make to order. That means you take the order from customer and you make. This is strategic pull. Strategic pulls here it is also known as takt based production. Takt time is the rate at which you need to complete a product in order to meet customer demand. Takt time is available production time divided by customer demand. So here suppose this takt time is working time available divided by customer demand. Suppose working time available is 450 units and demand for that production period is 50 units. So 450 divided by 50, 9 minutes. This is the takt time is required to pace up the production to meet the demand. Then manufacturing resource planning is MRP2. So MRP2 is material requirement plan plus some extensions. So here we have a resource requirement planning, aggregate planning, capacity requirement planning, and production activity and control. You see from production plan, how the production plans, what are the inputs from marketing department, from finance, from market demand, from manufacturing is the production plan. Then capacity plan. Adjust the plan. If there is a problem, then again you change the plan. If there is no problem, then you make master production schedule. Master production schedule is this. So it will tell that the final product is this. You have to produce in this much. Then it goes to MRP. So MRP the inputs of MRP is bill of materials and from inventory and master production schedule. So here it will decide that what are the components to make and how many to purchase and how many to make. So this is capacity planning. Problem, yes, again it goes to master schedule, production schedule, no. So this is Kanban system. Kanban is a type of pull system. Kanban is Japanese word for card or signal. Kanban system is a system of scheduling based on the pull system and uses Kanban or cards. It's sent from a downstream operation to trigger production or supply at an upstream operations. And the advantages, it increases productivity, visibility, efficiency, and identification problem. There is a card attached. So the Kanban is the Japanese name of card. So in the card, all things are written, flowchart type of thing. So if you see a card, you can able to know what the history and all. Now, cone whip and pulsa. Cone whip stands for constant work in progress. Here, it is also a pull-oriented production control systems where the start of each product manufacturing process is triggered by the completion of another at the end of the production. So here, suppose it ends here, then it goes to cone whip signal. It goes here, and they will produce. Okay. Then pulsa also, it is a paired cell overlapping loops of cards with authorization. Then theory of constraints and optimized production theory. Theory of constraint means, suppose there is a chain. What is the strength of the chain? Chains means there are different links. What is the strength? The strength of the chain is the strength of the weakest link. Suppose one link is weak, then the strength of the chain is that weak. So the theory of constraints is a methodology for identifying the most important limiting factor, that is the constraint that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer the limiting factor. So it is called the bottleneckness. You see, this is the bottleneckness. So here you identify the constraint. What are the limitations? You exploit the constraint. That means you strengthen this link, then subordinate and synchronize to the constraint, elevate the performance of the constraint, and repeat the process. So now we'll discuss a case study. This case study, here it uses your both pull strategy, and theory of constraint. Fleetguard is a filter manufacturing company. In India, it is a leading filter manufacturing company, world-class filtration solutions for all applications. It has 85 plus OEMs, right? Original equipment manufacturer is 85. That means almost all company they take from filter. It has 5,000 plus products, 200 plus distributors, 35,000 retailers, and 80,000 mechanics. It is OEM and OES, original equipment manufacturer, original equipment suppliers. Original equipment supplier means they give it to after sales. So this case is about Fleetguard filter, which have experienced higher inventory turns, higher market reach, and remarkable increase in return on investment by changing its distribution strategy from a push strategy to that of a pull strategy by adopting theory of constraint. So here we'll come to know push strategy, pull strategy, and theory of constraint. See, you see these are some products, and the Fleetguard filter is celebrating most preferred workplace of 23-24. And how this company is a consulting company. They uses theory of constraint. This is Vector Consultancy, and this Kiran Kuthekar is the main person. We'll see. This Fleetguard filters is a part of Cummins Group, American Cummins Group. It's a big group established in India in 1987. So up to 2002, it was dependent on OE sales only. That means all the filters they were producing, they were supplying to only OE, original equipment manufacturers. So this is your all vehicles, Tata, your Mahindra, Maruti, Hyundai, etc. So if you give to OE, they will take huge product, but your profit is less. They will bargain. right? And you don't have any control over OE cells. Suppose you want to increase at 30% space, you cannot have that 30% because according to the OE's demand, you have to supply. So there is no control over OE sales. So aftermarket sales started in 2003. So in 2003, they have started supplying to aftermarket. Aftermarket means suppose we are buying a filter from a retailer, that is aftermarket. So it is adopted traditional push strategy. Traditional push strategy means aftermarket, we consume, we get the material from retailer, retailer from distributor, distributor from manufacturer. So fleet guard filters to distributor to retailers to customer. So this is the traditional push strategy. So in the plant, filters were manufactured according to the forecast estimated by marketing department. So this is your pure push strategy. So marketing department, according to the forecast, they give it to the plant. So plant used to manufacture this pure push system. So this plant, distributors, retailers. So there is a mismatch between supply and demand, because as we have studied in forecast, there is always an error. And there was no retailer or garage visit of the salespersons. The salespersons of fleet guard used to sit in the distributors' premises and they used to get the order. So there was no actual feedback. Company was not able to get actual feedback. So the problem is piling of inventory, cash flow is less. So you push to distributor will push to retailer, but there is no sales. So piling of inventory, and in the month end, if you ask, distributor will ask the retailer will tell, "Sab, mera paas to maal hai, so how will I give money?" Then you get some cash discount. So you don't have any sell the material, but you are giving discount. So in 2006, Fleet Guard Filter started working with this Vector Consulting Group. We have seen this Kiran Kotekar. So this Vector Consulting Group, this is a consulting wing. So they studied the market and they suggested that to widen the reach, you have to widen 100% availability of material and increase the range of the product. So to increase the reach and increase the range. So in 2007, they opened central warehouses at Pune and depots in each state. And a software called Samanvay software, it controls the stock of distributor. And Humsafar software is also there. Mechanic loyalty program. That means the people here, mechanic sales representative, they used to visit all the mechanics, these 80,000 mechanics. They have given some gifts and they have given a passbook also to them. That suppose whatever they will use the fleet guard filters, they will keep it with them. So they have fixed route, fixed program. So accordingly, within 6 days or 9 days, even all the sales representatives, mechanic sales representatives will come to the garage. So garage people will have that passbook. They will give all the cartoons. So they will enter the items used. So the points, and that they will send to the fleet guard people. So as the point increases, according to the point, there are some gifts and all, right? So mechanics also, they are interested. So this passbook to mechanic sales representative collects this fixed day, fixed route program. So the inventory, you have tricolor inventory, red, yellow, green. When the inventory comes to yellow, you supply the material. Red means urgently you supply. So this is the results of 6 years of theory of constraints. So in 2007 and after, number of SKU, number of stock keeping units, because we have seen that to increase the reach and variety of products. Earlier it was 300, now it is 500. Inventory was 45 days, it reduced to 16 days, distributor inventories. Receivable 40 days to 11 days. Availability, monthly order fulfillment was 80%, now it was 99%. Number of distributors 60, it is 147. Area coverage by each distributor, there is no demarcation, now there are demarcation. So return on investment is 20%, here it is 80%. 20% is to 80%. Number of retailers cover 5,000 to 43,000. Number of sales officers was 26, here 70. So number of mechanic sales representatives 18 to 220. So here we see sales increase 9 times in 6 years. So previously they were using push system. Now they have changed to pull system by using the theory of constraints. So to conclude, we have seen the push system, pull system and push-pull system and the examples and all. Importance of material requirement planning and its computations. And MRP2 also we have discussed, Kanban also, and theory of constraint also. So this ends the session. Thank you for attending this session.